Welcome. In this presentation, we'll explore a Java program that checks whether a given number is prime. We'll be using concepts like class creation, constructors, and methods to implement the logic step by step. Let's start with the problem statement. We need to create a Java class named prime. It should have an integer data member called in. The class must include a default constructor to initialize in, a method to input the value, and another method to check and display whether the number is prime. Here is a summarized algorithm. We start by defining the class, initializing the variable, and taking input. The display method checks if the number is less than 2. If not, it loops from 2 to the square root of the number. If no factors are found, the number is declared prime. Finally, we test the logic using the main method. Here we define our class named prime. We declare an integer variable. The constructor sets in to 0, initializing it safely. The input method accepts an integer parameter and assigns it to the instance variable. This modular design keeps our logic clean and reusable. In the display method, we first assume the number is prime by setting isPrime to true. If the number is less than 2, it's immediately marked as not prime, since 0 and 1 are not prime numbers. If the number is 2 or more, we use a loop to check for factors. The loop runs from 2 up to the square root of n. Why do we use math sqrtn instead of looping all the way to n? 1. Because if a number is not prime, it will have at least one factor pair where one of the factors is less than or equal to its square root. For example, if n is 36, then 6 times 6 equals 36, and if there's any factor greater than 6, the corresponding pair will be smaller than 6. So checking up to the square root is enough to determine whether a number has any factors. This greatly improves efficiency, especially for large numbers. Continuing from the previous slide, we now look at the rest of the logic inside the display method. In this part, we complete the loop that began in the previous slide. Within the loop, we check if n is divisible by I, using the condition n%i equals 0. If this condition is true, it means I is a factor of n, and hence, n cannot be a prime number. At this point, we immediately set isPrime to false and use a break statement. The break command exits the loop early, which saves time. There's no need to continue checking once we already know the number is not prime. After the loop ends, either because no factor was found, or because we exited early, we move to the final decision step. If the isPrime flag is still true, we print that the number is a prime number. Otherwise, we print that it is not. This structure makes the program both efficient and accurate. It avoids unnecessary checks and clearly separates the conditions for prime and non-prime numbers. Using a Boolean flag like isPrime is a common and clean way to track conditions in such problems, instead of relying on return values or multiple print statements. The main method is used to test our class. We create an object of the prime class, call the input method with a sample value like 29, and then invoke the display method. This structure separates data handling and logic execution for better clarity and maintainability. In this slide you will get the full program link which you can execute the entire program. Also, program link is available in the description box. This table describes the variables used and stores the number to be checked. X is the value passed to input. I is the loop variable used for iteration. isPrime is a Boolean flag that helps us decide the result of the prime check. Here's the output when we test the program with the value 29. Since 29 is a prime number, the program prints 29 is a prime number. You can change the input value in the code to test other cases like 1, 4, or 17. Let's quickly recap. We created a class with a constructor, an input method, and a display method. The logic checked if the number was divisible by any number from 2 to its square root. This helped us determine whether the number is prime in an optimized way. Here are the key takeaways. A prime number has only two factors, 1 and itself. Use math.sqrt for efficient checking. Always initialize variables properly in constructors. Organize your class code clearly with separate methods. And finally, test your code thoroughly with various inputs, especially edge cases. Thanks for watching. Documentation containing question, algorithm, Java program, variable description table, VDT, sample output is also available in description box of this video. Don't forget to subscribe if you are using this for your school or college projects. Happy learning!